electrical measurement. So for the BMFG and BMFI students, I believe you have already also taken the basic subjects of electrical systems, like principle of electric and electronics, electrical circuit, I believe, electrical circuit 1, basics of electrical circuit. So we are going to go through a bit on the principles of electrical circuit in order to answer the questions in this tutorial. But don't worry too much if you don't remember. I'm going to show you at least step by step for the questions available in this tutorial. Okay, so question 1 is a theoretical question. So when we want to explain about systematic and random errors, why is someone requesting hold on, I need to do some setting. Oh, why is the code different? Yeah, this is typo. Actually, this was the old code for the name of this subject. Now it's already new subject. So I'm going to later on, maybe I'll change it. I didn't notice it. So thank you. Muhammad Zakirin, tak dengar voice. Orang lain dengar tak? Dengar kan? Tadi yang lain respon.
Dengar, sir.
Dengar, sir.
So maybe Zakirin from your side lah. Okay, so kalau tiba-tiba terputus, kadang-kadang line sebab saya pakai wifi. I'm using wifi line. So maybe kalau terputus, please let me know in the chat so that I am not talking alone. Okay, so let's go straight to the question. Answer question 1 is theory. So I hope you can answer or refer to the lecture note. What is the difference between systematic error and random error? I want to move to question number 2. So the question number 2, a circuit measurement of resistance of 550 ohm is satisfied by connecting together two resistors, 220 ohm and 330 ohm in series. If each resistor has a tolerance of plus minus 2%, calculate the error, both absolute and percentage. Okay, so let's start with this one. This one is quite simple. Okay, hold on. Ada pelajar request untuk join. So ramai. Okay, siapa yang dah request tu saya dah approve. Kita bagi masa sikit beberapa second sebelum kita proceed. Okay. So question number 2. We have two resistors connected in series. One is 220 ohms and the other one is 330 ohms, is it? Yeah, 330 ohms. So this is 220 ohms. So the error is plus minus 2% for each resistor. So the total must be 550. So the question is, what is the error in percent and absolute? So the answer is straightforward. First, we calculate what is the absolute value for each of the resistor. So for resistor 1, we have 2 divided by 100 times 220. So we get the answer is 4.4. And for the second resistor, we have 2% times 330. So we have 6.6. So we add them, we get the answer as 11 ohms. Now, when we want to calculate the percentage error, so we get 11 divided by 550. So 11 is 11 ohm, 550 is also ohm, so it's going to cancel out, times 100%. So you are going to get 2%. Okay, so the answer should be this one is the absolute error. And this one is the percentage error. Now, actually, the percentage error is a given since both have the same percentage of tolerance in terms of error. So basically, because it's 2%, when we add them together, the answer is also going to be 2%. But this is just a proof through calculation. So this is how to answer question number 2. Okay, now let's move to question number 3. So question number 3 is exactly similar to the example available in the lecture note. But for clarity, let's just repeat the steps to make sure that you grasp the concept. So the question is, the current through a resistor is 1.5 amps. So this is the expected value, 1.5 amps. But the measurement yields a value of 1.46 amps. So we need to compute this error. So if you refer to the lecture note, then you should refer to this slide here, where all the equation is given. Yeah, this slide here. All right. So let's do the exercise together. I hope you are doing this exercise together with me, so that we can you can save some time later. So the expected value for some reason, hold on. Okay. So the expected value Yn is given as 1.5 amps. But the measured value Xn is given as 1.46 amp. So of course the error is going to be the expected value minus the measured value. So we have 0.04 amps. And then to calculate the percent of error, we replace the value from the equation given. So we have magnitude Yn minus Xn divided by Yn. Okay, so for this part, make sure you be careful. Always replace this value here with the expected value, not the measured value. Okay, sometimes students tend to make mistake when they put the value below here. And then multiply with 100%. So you get magnitude of 0.04 divided by 1.5 times 100%. Now, if you do the subtraction on top, yn minus xn, and you get a negative value, then you need to convert it into a positive value. Because we want to know what is the percent difference, we are not concerned with the sign, whether positive or negative. Okay, but for absolute value, you need to consider whether it's positive or negative. So if you put this value in your calculator, you will get the answer is going to be 2.66666. So we take it as 2.67%. It is sufficient. Okay. So now we want to calculate the relative accuracy. So relative accuracy is capital A. So capital A is given as 1 minus the value on top here, 1 minus yn minus xn divided by yn. So we have is going to be equal to 1 minus the modulus of 0.04 divided by 1.5. So the answer is going to be 0.973. Okay, this is more accurate than the answer given and in the solution at the solution part. So this one is percent. Okay, so if we want to calculate the percent accuracy A, we can use either 0.973 times 100%, which is easier. We get 97.3%. Or we can also use 100% minus the error, 2.67%. We are also going to get, if we take this one, 2.67. So 100 minus 2.67. Hold on, let me fetch my calculator. So 97.33%. So both are acceptable answers. In fact, if I do the calculation for the top one, 0.04 divide by 1.5, 1 minus answer. So if I take another decimal point at the back, it should be 0.973. Okay, so by right, the answer, whether you use the top method or the bottom method, you should get the same result. So this one is also 97.33%. Okay, so fairly straightforward, these two questions. Okay, kalau ada soalan ataupun tak clear, please let me know in the chat. I'll be continuously checking it out from time to time. Okay, question number 4. 6 students using one oscilloscope measures the output voltage of an amplifier and has found the following reading. So they take each student take one reading and then they compile the reading together. So these are the value for each of the students' reading. So calculate the precision of the fourth measurement. So the fourth measurement is 20.05. So which of the above measurement is the most precise? So if you look at the lecture note, we go to the precision. We want to utilize this equation here. Okay, so question number 4. We have the precision equals to 1 minus the modulus of xn minus xn with a bar on top and divide by xn with a bar. Okay, so these are average values, yeah? So these are these two are average values from the whole reading measurement. So what you guys need to do is you need to find the average from these 6 measurements lah. So if you add them together using a calculator, you are going to get the total reading is going to be 120.05. Okay. So the sum of the reading is going to be equal to 120.05 ohms. So the average xn with a bar is going to be 120.05 divided by the total number of reading 6. So I am going to get 20.0083. Okay. So now the question was find the precision of the 4th reading. So we want to find what is the value for the precision for x number 4, the 4th reading. So to solve it, we just replace the value lah. P equals to 1 minus, so x4 is equal to, what is the 4th reading? 20.05. 20.05 minus 20.0083 divide by 20.0083. So if you calculate this one, you should get the same answer as in the answer part of the question, which I think is 0.9979. If I'm not mistaken, I'm just quoting from memory. Let me double check. Yep, it's correct. 0.9979. Okay, so okay, saya baru nak jawab soalan Kushairi ni. For the answer X bar, which is the average, how many decimal points should you consider? Boleh tak? Can we take, instead of 20.0083, we take as 20.01? Is it acceptable? Well, the answer is it's going to depend on how precise you want to be. Kalau you tengok dekat soalan ini, kalau you gunakan 20.01, okay, kalau you ambil 2 titik perpuluhan saja, you akan dapati semua bacaan dia 0.99. Ataupun dekat-dekat lah, 0.98. You'll find all the values you cannot differentiate. Okay, so that is why for this question, we need to consider until the 4th decimal point. But depending on the question, sometimes when the reading is not too close, not too precise, in those conditions, you can consider up to 2 decimal points or 3 decimal points. So there is no fixed answer to the question posed by Kushairi. It is going to depend on how precise you want to measure and what are the difference of the values from the data that you gather. So that's how we define lah. Okay. The rule of thumb macam mana? Biasanya kalau jawab soalan test, soalan final macam mana? Secara amnya, the student's answer can vary between 2 to 4 decimal point. Okay. Katakan you pakai 2 decimal point, you dapati semua you punya precision 0.99 macam ni. Tapi sedangkan you punya bacaan berbeza. That means you need to add at least another decimal point so that you can differentiate what is the difference. Okay. Kita sentuh pula secara realiti. Katakan you bekerja dekat industri. How precise do you need to go? The answer is still going to be depending on the field that you are venturing into. Kalau you buat measurement untuk pasang IC atau transistor kepada you punya motherboard ataupun chip komputer, then your accuracy needs to be very precise. Sebab transistor tu size dia nanometer. So you need to set your machine bila dia pasang transistor tu, it's going to be exactly at that point. Almost no error. Tapi kalau katakan you terlibat dalam kerja pemasangan kabel, then your accuracy is going to be a bit relaxed. Then you need to you can adjust accordingly. Ada orang on mic ke? Ada soalan ke?
Ya, sir.
Ada yang turn on kot. Okay, moving on. Soalan next. Okay, soalan nombor 5. Two currents from different sources flow in opposite direction through a resistor R1. I1 is measured as that value. It uses analog instrument. Accuracy plus minus 3% of full scale. I2 is determined as 31 milliamps. Measured on a digital instrument. Satu pakai analog, one uses analog, one uses digital. And the accuracy is plus minus 100 microamp. So calculate the maximum and minimum levels of the current in R1. Okay, to understand this question, we need to be able to convert from the description into a figure or a diagram. Okay, so two currents from different sources flow in opposite direction through a resistor R1. Okay, so how do we visualize this? You ada satu resistor R1. Kemudian you have two different sources of current. Okay, so let's say I put one current here, one current source here. Okay, connected to this point. Okay, so this is let's say this is source number 1. This is source number 1. So using conventional current is flowing here. This is I1. And then we have another source. This time it's reverse. This is source number 2. It's also connected to the same resistor. So this is current I2. So in the resistor, the current from this source on the left here travels like this. This is I1. And for I2, the current travels like this. This is I2. So we can say that the current in the resistor R1 must be I1 minus I2 or I2 minus I1. Depends on which is the higher current. Okay, so going back to the question. So I1 is measured as 79 milliamp on a 100 milliamp analog instrument with an accuracy of plus minus 3%. And then I2 is 31 milliamp. So let's settle that part first. So I1 is 79 milliamps and I2 is 31 milliamps. So we are going to have 48 milliamps. This is the total current flowing in the resistor. But now we need to calculate what is the minimum and maximum level. So first we need to calculate for I1. For I1, accuracy is plus minus 3%. 3% of full scale. So we have 3/100 multiplied by 79 milliamps, which is what is the reading for meter 1. So 3 divided by 100, 3 divided by, sorry, not 3 divided by 100, it should be 3 divided by 79. So I should write it like this, 3% times 100 milliamp, so I'm going to get 3 milliamp. This is the absolute error for full scale. Now I calculate, okay, so 3 milliamp is the absolute error for meter number 1. So for meter number 2, the error is already given as plus minus 100 microamp. So this is equivalent to plus minus 0.1 milliamp, because 100 micro is equivalent to 0.1 milli. So now we can add this together to get a total value of 3.1. So we add this together from meter 1 and meter 2. We get, it's going to be plus minus 3.1 milliamp. So our answer should be 48 milliamp plus minus 3.1 milliamp. Okay, so if you do 48 plus 3.1 milli, you are going to get the maximum value is 51.1. So 48 plus 3.1, you are going to get 51.1 milliamp, and 48 minus 3.1, you are going to get 44.9 milliamps. Okay, this is the answer for question number 5. Okay, someone is still requesting. Okay, hold on. Okay. So I'm still not familiar with the how you add the members. I thought if you give the code, you can automatically join. So I'm not sure what happens. Maybe you can advise me on that if you know. Okay, so this is the solution for question number 5. Now, let's move to question number 6. So a resistance box has the following criteria. It has 10 resistors for each of the value here. You want to basically combine the resistors to get a total value of 453.72 kilo ohms. Okay, so what is the combination for you to get 453.72 kilo ohms? Of course, if you see here, 400, so you need 4 resistors from this category. So 50, you need 5 resistors from this category, and so on. So let's do the calculation. So the value that we want is 400 453.72 kilo ohms. So you need to have for the 100 kilo ohm, you need to have 4. For the 50 kilo ohms, sorry, the 10 kilo ohms, you need to have 5. For the 1 kilo ohm, you need to have 3. For the 100 ohms, so 100 ohm is equal to 0.1 kilo ohms, yeah? You get 7. And for the 10 ohms, you get 2. So you are going to get here we are going to get 400 kilo ohms. Here we are going to get 50 kilo ohms. Here we are going to get 3 kilo ohms. Here we are going to get 700 ohms. So 700 ohms is equal to 0.7 kilo ohms. And here is going to get 20 ohms. So 20 ohms is equal to 0.02 kilo ohms. Okay, next we need to multiply all this value here with the corresponding error. Here we have 0.05 for the first 3, and then we have 0.1 and then 0.5. That is the percentage error of each resistor. So let's multiply all of them. Here we multiply by 0.05%. So I am going to get 200 ohms. Here also 0.05%. So I'm going to get 5 times 5, 25 ohms. Here also 0.05%. Okay, Aisha, hold on. Let me answer after this. 1.5. So 1.5 ohms. And then this one is multiplied by 0.1%. So equal to should be 0.7. 0.7. And then this one times 0.5%. So I'm going to get 0.1 ohms. So now I add them all together. So the total is 200, 20, 26, 26.2, 26, 27.3, 227.3 ohms. Is it the same answer? Yeah, same answer. So this is the error in terms of absolute numbers. Okay, so the question from the chat, each resistor must be based on total resistor. Aisha, I don't understand your question. Can you please rephrase? Quantity each resistor must be based on total resistor. Based on value yang kita nak lah. Sekarang ni target kita nak value ni 453 ni. So the question, they give you this one, this resistor. So you need to combine the resistors to get this value here, 453.72. So that's why you get this combination. So now we can calculate to find what is the percentage of error or percentage of tolerance. Okay, Aisyah faham. So harapnya yang lain pun faham juga. So we have 227.3 divide by 453.72 lah. 0.72, this one is ohms, this one is kilo ohm. So unit, please be careful ya. Jangan tertinggal yang kilo-kilo ni ataupun you miss out something. And then you multiply by 100%. So the value I get is 227.3 divided by 453.72 kilos. It's 0.05%. Okay, so if we write, hold on. So the proper way to write is we write like this: 453.72 kilo ohms plus minus 227.3 ohms. This one is absolute. Or 453.72 kilo ohms plus minus 0.05%. This one is percentage. Okay, what is the meaning? Bila kita kira ni, what is the meaning? When you do your experiment, nanti kalau you dah balik ke UTM, you pergi dekat lab, you buat eksperimen, you ada error. What does it actually mean? Okay, so soalan daripada soalan 2 sampai soalan 5 ni, we want to identify what kind of error you are going to encounter. Okay, kalau kita kira 453.72 kilo ohms plus 227.3 or minus, so you are going to get a range. Okay, let's go back to the previous question just now, question number 5. Yang ni kan? Okay, so this is question number 5 just now. So when you calculate, you get this range. 44.9 will be the minimum range, 51.1 is the maximum range. So katakan masa you measure, you use your ammeter, you measure, you find the value is within this range. Let's say you get 45 or 49 or 50 or 51. That means your reading is within the expected value. Okay, so you tahu ini adalah dia punya range disebabkan limitation of the error for each meter. Tapi katakanlah ketika you measure, tiba-tiba you dapat value keluar daripada range ni. Bila you measure, you dapat value dia tiba-tiba 52 or 53 or 41. Then you dah tahu sekarang ni ada lagi error. Dia bukan lagi error yang disebabkan oleh instrumen punya limitation, tapi mungkin ada error lain. So what kind of error that can come from when the reading is out of range. Mungkin you salah baca. Human mistake, so we call it as gross error. Mungkin ada systematic error. Misalnya instrumen tu ada kerosakan. There's some fault in the instrument which makes the reading out of range. So by having this knowledge, when you have a reading, you can verify whether your reading is acceptable or not acceptable. Lepas tu, bila you buat report, barulah report you, kalau ada lab report, barulah report you akan ada quality. Sebab you faham apa maksud error yang you dapat. Dan you boleh analyse further. You tengok, okay, adakah disebabkan bacaan kawan you salah ke? Ataupun setup you punya measurement tak betul ke? Ataupun ada fault pada bahan yang you measure ke? So macam-macam boleh bincang dalam report. Dan kalau you apply, if you apply that to real situation pun dia akan jadi menarik. Bila you buat sebarang projek, you buat assignment, ataupun you ada aktiviti di luar kelas, bila you buat measurement, you sekarang dah tahu, oh okay, error ni, is it reasonable or not reasonable? By identifying whether the error is caused by the limitation of the instrument or there may be some other factors. Sama juga dengan soalan nombor 6 ni tadi. Question number 6. Did I open the wrong one? Okay. The same goes for this part here. So once you calculate, you get 453.72 kilo ohm plus minus 227.3. Okay, so you kira lah kalau plus ni you dapat berapa, minus you dapat berapa. Katakan bila you measure dia punya resistance, value dia keluar daripada range tu. So you boleh, mungkin ada salah satu, there's one of the resistors that is damaged, which is causing the reading to be wrong. Or maybe your meter is faulty. Or maybe you have a mistake when you do the reading. Then this is why understanding what the error is all about is important. The further you go along the line, bila you masuk tahun 2, tahun 3, tahun 4, the more we care about error. So that we can identify whether our measurement or whether our design is correct or not. Which is why this subject is crucial for your fundamental. Okay. Question number 6 is done. Let's move to question number 7. Okay, question number 7, we are going to move into statistics. So before we move to statistics, let's take a short break. So now it's 11:47. We take a break until 11:55. Then we continue. Okay, we're going to start in 1 more minute. Okay, so let's continue with question number 7. So the question asks 8 different students, okay, do the reading and found the frequency. It has 8 different measurements. Is it different? Yeah, all different. Okay, there's one reading the same, reading number 3 and reading number 7, but it's okay. So compute the arithmetic mean, average deviation, standard deviation, probable error of one reading, and probable error of mean. Okay, in your lecture note, if you refer to the statistics part, you can find the corresponding equation here. But there are 2 equations not available, which I overlook. So I'm going to update this slide to include the value or the equation, which is question on the probable error of one reading and probable error of mean. Okay, so you need to calculate the average. To save some time, I am just going to use the answer given here. So when you find the average for this value, this should be the answer that you are going to get. So for this question, because there is no decimal point for the reading, it's sufficient to take until 2 decimal point. It's good enough. You don't need to take until 4. Right? And then this is the average deviation. And then this is the standard deviation, 6.54. If I were to draw the distribution, assuming this is a normal distribution, I am going to get something like this. So for question number 7, if we assume that it is a normal distribution, so this is going to be the mean. Okay. So this is going, the center point here is going to be the mean. So the mean is equivalent to, what was the value again? 539.25. So here, the center point here is going to be 539.25, and the unit is kilohertz. Okay. Then the standard deviation sigma is given as 6.54. So if I were to draw the sigma, it's going to be somewhere around here. So this is the value for sigma. So this is going to be positive sigma and this is going to be negative sigma, the range of the standard deviation, where sigma is given as 6.54 kilohertz. Okay, if we look at the lecture note, you will find that if I refer to the lecture note, if we look at the statistic here, we find that that is going to be 68%. 34.1 plus 34.1, you're going to get roughly 68.2. So we take it as 68 lah. So this is the range of the reading that you're going to get. Okay. In this example, in this tutorial, you do only 8 measurement. So 8 measurement is very small sample. So let's say you repeat the measurement of 100 times. Okay, you repeat the measurement. Assume lah you repeat the measurement 100 times. Then when you get this value here, in theory, 68% of your reading should fall within this range. Okay. Dalam range ni, yang antara sigma ni, 68% of your reading should fall within this range. Itu dia punya konsep lah, idea dia. And then, if you were to extend for 2 sigma, katakan you ambil sekarang for 2 sigma, let's say it's value here. This one is plus 2 sigma. And here is minus 2 sigma. Okay, it should be equal lah on the left hand side, on the right hand side, but my writing may not be that accurate. So I hope you can understand. Sepatutnya jarak ke kanan ni dengan ke kiri ni mesti samalah nilai dia sebab dia normal distribution. Alright. So if from plus 2 sigma to minus 2 sigma, then the range should be 95%. Ini range kat sini should be 95%. Maksud dia, kalau you buat 100 measurement, you measure 100 times, around, tak semestinya tepat, around 95 times of the reading, the value is going to be within this range. 539 plus 2 sigma or minus 2 sigma. Okay, and then kalau you extend lagi, satu lagi, for plus minus 3 sigma, kata you ambil sini pula. Okay, ni plus 3 sigma. Allah. Colorful sangat. So plus 3 sigma. So here also plus minus 3 sigma. So you are going to get 99%. Sini 99.7%. Maknanya hampir kalau you buat 100 kali bacaan, sepatutnya 99 hingga 100 bacaan akan jatuh dalam range ni. Itu menunjukkan bahawa you punya distribution adalah normal distribution. Okay, itu konsep dia. Okay, moving back. Itu yang saya highlightkan dekat sini dalam slide ni. This one, on the right hand side here. So the more reading you take, then the more is going to follow the concept of normal distribution. Ini terpakai untuk kebanyakan jenis data, tapi tak semua. Okay, tapi sebab sekarang ni kita baru introduction, jadi kita ambil case yang biasa-biasa dululah. We take the normal cases first. Later on, once we understand the fundamental, bila you ambil subjek lain, you're going to get into more detail. Okay, what is the question just now? Apa yang tak jawab lagi? This one, probable error of one reading and probable error of mean. So I'm going to give you the equation now. So for a probable error, oh, hold on, something is okay. Let me try again. Alright, right. Probable error of one reading. We use it as R, small r. So R is going to be equivalent to plus minus 0.6745 multiplied by sigma. Dari mana datang 0.6745 ni? Where does it come from? This value actually come from statistic analysis. Comes from statistical derivation. Okay, actually it's related to the 68% right range of the sigma. But more accurate, the value is going to be this value, 0.6745. So in this lecture, I'm not going to cover how this value is derived. We are just going to use this value. So we just multiply lah. So let me put it here. So R equals to 0.6745 multiplied by the standard deviation, which is what was the value just now? 6.54. Yeah, 6.54. So I'm going to get the value is plus minus 4.41123. What is the unit? So the unit here is kilohertz. This one has no unit, so this one is also kilohertz. So this is the range of probable error for one reading. Bila you baca satu bacaan, dia punya range of error within plus minus 4.41123. Okay, then probable okay, question from Darshini. So, Doctor, the value of 0.675 remains the same for all the probable correction? Yes, for normal distribution. If your distribution is normal, like this one, yes. There will be other cases where the value here is slightly different depending on how we derive. It can be, for example, 0.682. If you refer to different books, then there will be slight differences in the value of the constant there. But in our class, we are going to use this value. So to answer the question, yes, it's going to be the same, 0.6745. Okay. Now the last part for question 7, probable error of one reading. So probable error, probable error of mean. Sorry, probable error of mean. So probable error of mean, the symbol is given as RM, error of the mean. So the equation is given as Rm equals to R divided by the square root of n minus 1, where n refers to the number of reading, number of measurement. Okay, so just replace the value. So I'm going to get 4.41123. Divide by square root of, what was the total number of reading just now? 8. So 8 minus 1. And we are going to get 1.6673. Is it the same? Yeah, same. So this is how you solve question number 7. Okay. Moving on. Question number 8. Okay, question number 8. Oh, lambatlah dia keluar, kejap. Okay. So question number 8, the unknown resistance is determined by Wheatstone bridge. Wheatstone bridge, actually the theory we are going to cover in chapter 6 when we go about bridges, electrical bridges, to measure values of resistance, inductance and capacitance. But for this question, the equation is already given here. Rx is equal to R2 multiplied by R3 divided by R1. So where R1, R2, R3 is given with these tolerances, with this range of error. So determine the magnitude of the resistance and the limiting error in percent and ohms for the unknown resistance. Okay, so first we need to identify what is the relationship between all the variables or all the parameters in the equation. So we see it's multiplication and division. We need R2 multiplied by R3 and then divide by R1. So in this case, we need to add them. This question refer to this slide here. In your lecture note, you need to refer to the slide on summation of error, which is this slide. Okay, hold on. This slide. Slide number 44. Okay, so let's go a bit about the summation of error. The maximum absolute error in sum of two quantities or more. Tak semestinya dua saja, not necessarily only two. So depend on the equation, on how many variables are in the equation. Is equal to the sum of the absolute errors in the individual quantities. Okay, you refer to the table here for the math operation. Kalau you tambah, if you add or you subtract, you need to add the absolute error or subtract the absolute error. The summation is the summation of absolute error. If you multiply or divide, the summation is the percent error. Okay, this one is the absolute error, this one is the percent error. So kalau saya refer balik pada table ni, let's look back at question number 2 yang mula-mula kita jawab tadi. Not here. Mana tadi question number 2? Which one? Okay, so question number 2 ni tadi, we have two resistors in series and the value is absolute value. So in terms of percentage, we don't add the percentage. Jangan buat kesilapan tambah percentage, sebab bila you kira nampak percentage dia actually the same percentage. What we need to add is the absolute value, which is what we calculate here. 4.4 plus 6.6. So that is what is meant, because we need to add these two together. That is what is meant by the lecture slide. For addition, you need to add and subtract the absolute error. Yang ni, absolute error. So, kalau untuk tambah dan tolak, just as a reminder, jangan tambah dia punya percentage. The percentage, macam case ni, you jangan tambah jadi plus minus to 4%. Salah nanti. Okay, it should be absolute error. Okay, now, but for multiplication and division, you can add all the errors together. Tak kisah sama ada dia darab atau bahagi, you tambah semua. Doesn't matter whether it's multiplication or division, all the errors you sum together. Okay, so let's look at the question again. So Rx equals to R2 multiplied by R3 divided by R1, and then we have the following error. Now if you look, this is the percentage error. So if you add 0.5 plus 0.8, you get 1.3%. 1.3 plus 0.6, you get 1.9%. Already directly you get the answer for the percentage of error. Okay, so now let's do this question. This is question number 8. Okay, question number 8. So Rx is given as R2 multiplied R2 multiplied by R3 divided by R1. So we have what was the value again? R2 is 900 ohms multiplied by 825 divided by 90. Okay. So I have 900 multiplied by, I forgot again, by 825 times 825 divided by 90. So I am going to get 900 multiply 825. Alah, apa yang susah? Why am I? Ni je lah, sini potong, we get 1. Okay, 10. So 8250 lah. Equals to 8.25 kilo ohm. Okay, this is the expected value. So Rx is equal to 8.25 kilo ohm. Then plus minus, so we add them together, 0.5% plus 0.8%, 1.3 plus 0.6%. So you get 8.25 kilo ohms plus minus 1.9%, or equivalent to, so 1.9 divided by 100 times 8250, we are going to get times 156.75. So the answer is Rx equal to 8.25 kilo ohms plus minus 156.75 ohms. So this is the percent and this is the absolute. Okay, this is question number 8. Okay, banyak kita ulang-ulang yang lebih kurang sama. I hope you have the idea by now. Okay, betul. Okay, next question number 9. 0 to 150 voltmeter has guaranteed accuracy of 1% of reading. If the voltage measured by this instrument is 83 volt, calculate the limiting error. This is straightforward. So, okay, never mind lah. I'll just show. So 1% is for full range, 150. But if your measurement is 83 volt, you need to calculate in terms of percentage. It's not going to be equivalent to 1%. This, for question number 9, you need to refer to the slide for limiting error, this part here. So the example is already given there. Okay, so just for clarity, let's just do it. So for question number 9, the error is 1%, the range is 150. Okay. So 1 over 100 times 150 volts. So you are going to get 1.5 volts. This is that's the absolute error for full scale. Okay. This is the absolute error for full scale deflection. So now the reading just now was 83. So 1.5 volt divided by 83 volts multiplied by 100%. So the volt and the volt cancel. I'm going to get 1.807%. The answer was 1.1. Betul lah, sama je. Just a matter of decimal point. Okay, senang soalan ni. Okay, question number 10. A little bit more, 2 more questions. Okay, what time? Okay, 12:21. So I think we don't have time to go into our lecture today. Even if I go into the lecture, it's going to be only going to cover a few slides. So maybe after this tutorial, I'm just going to provide a brief overview before we go into the lecture tomorrow. So tomorrow we have 1 hour lecture for BMFG and BMFI. And on Wednesday, 12 to 2. Can open answer. Okay, sure. Let's open question 9 first. And then I'll go back to question number 8. Because question number 9 is simple. Okay, Zakiri, let me know if you're finished, number 9. Okay. Question number 8. Okay, finish. Okay, question number 10. A resistance in a circuit. Tak keluar. Kejap. Alright. Question number 10. A resistance in a circuit is 470 ohm plus minus 10%. When a meter with a full scale voltage of 25 volt, error plus minus 3% is used to measure the voltage across the resistance. The voltage was read as 12 volts. Okay. So obtain the power across the resistance and determine its error. So how do you solve this? Resistance in a circuit, when a meter with a full scale voltage, the voltage reading was 12 volt. Okay. Okay. 470 ohms. So for the next question, we have a resistance. $470 ohms plus minus 10%. And of course, when you measure, it must be connected to a source lah. We don't know what source. You don't actually need to draw this. I'm just visualizing it for you. Okay, this should be the circuit lah, roughly. And then you connect this part to a meter, to a voltmeter. Okay, so you put your probe here to measure what is the voltage. Oh, jangan confuse pula, ini bukan current. This is the connection point of the probe. Okay, bila you measure voltage, you sentiasa kena measure dua titik, dua point. Kalau you measure satu point je, you takkan dapat value. So biasanya kita akan letak satu probe kita dekat ground dan satu probe kita dekat satu lagi bahagian di mana kita nak measure. So biasanya kita ambil bahagian bawah ni sebagai ground lah. Ini term untuk electrical. Okay, so the meter is 25 volts. The reading is 12 volts. And the question was obtain the power. Okay, obtain the power. Power is given as P in electrical. Okay, for DC. Okay, for DC circuit, the equation to calculate power is given as voltage multiplied by current. Okay, and from Ohm's law, we have voltage equal to current multiplied by resistor. So we can modify the equation because now we have power equal to voltage times current, but we don't have current here. We only have the value of voltage. So we have the value of V, and here we have the value of R. V is here, so we can modify this equation. So we can convert this equation into I equals to V divided by R. And then we replace the value of I here. Sorry, not this one. The value of V over R here into I here. So we are going to get P equals to V multiplied by V divided by R. So we have V squared divided by R. Okay, so we have P equals to V squared divided by R. So P equals to V squared divided by R. So now it's just a matter of calculating. So the full scale for the full scale of the meter is what? The power. Okay, let's calculate the power first. So the power should be 12 squared divided by 470 lah. So the reading is 12 squared. Okay, so P equals to 12 to the squared divided by 470. So 144 divided by 470, you're going to get 0.3064. 0.3064 watts. The answer was only until 3 decimal point. Okay, so I just take 3 decimal point lah. Okay. And then for the error, so the error by right, you should take the error from the meter itself, and then you should add them together because it's V multiplied by V divided by R. So let's calculate the percent error for the voltmeter. For the voltmeter. So the voltmeter is given as plus minus 3%, full scale voltage of 25 volts. Okay. So 3 divided by 100 times 25. So we are going to get equal to 0.75 volts. So the reading is 12, so 0.75 volts divide by 12 volt multiply by 100%, you are going to get 0.75 divided by 12 times 100, you are going to get 6.25%. Because the voltage cancel out. Okay, and then because we have P equals to V squared divided by R, so that means the percent error is going to be the percent error of the total. Error for power is going to be percent of delta plus percent of delta V because we have V squared, and then divide by R plus percent of delta R. So we have 6.25 plus 6.25 plus 10. 6.25% plus 6.25%. What is that? 12.5 lah. Plus 10% of the error. So 12.5 plus 10% is going to be 22.5%. So this is our answer. Our answer is going to be, if I were to write it down again, should be, so P equals to 0.306 watts plus minus 22.5%. So 22.5% ni besar tak? Let's calculate the absolute value just for out of curiosity. Dalam soalan dia tak tanya, saya rasa. Dia tak tanya. Tapi kalau kita tengok kat sini, if you look here, 22% is quite a large error. So let's calculate. So 0.306 multiplied by 22.5% is going to be 0.6885. Let me take until here 0.069 watts, because this is watts. Okay, then $22.5. No, not 22.5. So 0.306 plus 0.069, we are going to get 0.375, and then 0.306 minus 0.069, we are going to get 0.237. Okay, so you can see from here that the range is quite big. The reading is small, 0.306, less than 1 watts. But the range of error is 22.5%. So 0.237 and 0.375. So let's say you encounter this kind of measurement, this kind of error in your actual application. Whether you do your experiment, whether you do your project, whether you do, maybe you do some part-time jobs. Katakanlah you jumpa benda macam ni. So what do you think about the accuracy? Is it acceptable or not? So this is an open question, bukan ada jawapan yang khusus. So based on your justification, on your opinion, then you should, and based on experience, then you can identify whether this value is acceptable or not, and how you can probably do something to reduce error, to minimize. Okay. Then question 11. Question 11 state the type of error je. State the type of error that occurs in the following situation and suggest one method to reduce the error. Okay, a person using an ohmmeter reads the measured value as 470 ohms when the actual value is 47 ohms. Alright, so boleh tak you update dekat chat? What do you think is this type of error? Ada beberapa orang bagi respon. The reading is 470 ohm, actual value is 47. What kind of error that can cause this kind of wrong reading? Is it gross error? Is it systematic error? Or is it random error? Ingat lagi tak teori? Did you remember what I shared with you last week? Okay, systematic error. Okay, gross error I guess. Gross error. Systematic error. Okay, so we have varying answers. Observational error. Instrumental error. Alright. Okay, thank you. Random error. Ada juga yang jawab random error. Okay, very answer. Okay, mari kita clarify. Mari kita tengok slide untuk kita tentukan yang mana satu. Sekejap, atas saya rasa. Okay. Okay, so kita recap balik what we studied last week. There are 3 types of error: gross error, systematic error, and random error. Apa dia? So gross error are mainly due to human mistakes, such as reading the value, salah baca value. Using the instrument, salah, maknanya salah manusia tu sendiri. and recording observation. Masa dia salin nilai tu salah. Itu maksud dia. Okay, can be minimized by being careful when taking measurement. Alright. Ada yang jawab instrumental error ataupun systematic error. Mari kita tengok. Systematic error, what does it mean? Systematic error is predictable error. That means is always affect the reading by the same amount of proportion. Maknanya kalau you baca reading tu kali kedua atau kali ketiga, you akan dapat nilai yang sama je. Dia lari dia sama je. This is what we call as systematic error. Jadi kalau kita tengok soalan dekat sini, dia bukannya nilai dia terlalu jauh. Beza dia antara 47, 47 and 470. Okay. If it were to be an instrument error by right, the value should not be that far away. Okay, because this is only one reading, perhaps it's possible. But if you take multiple reading and you have different value, not 470, let's say you take 10 readings, the others are all 48, 49, 50, right? Then only one 470, then we can definitely determine that is from gross error. That is why in the slide, when we refer to gross error, there's a statement here: conduct measurement at least 3 times. You need to do multiple measurement just to make sure that your reading is correct. Sebab kadang-kadang bila kita buat measurement, ada masa kita tahu teori di sebalik tu. Kita faham, oh ni macam ni. Dan kita boleh kita boleh estimate sepatutnya value dia dalam berapa. Kadang-kadang kita buat measurement, kita masuk lab, kita buat eksperimen, kita tak belajar lagi benda tu. Jadi kita tak tahu teori di sebalik tu macam mana. Jadi bila kita measure, kita dapat value, kita salin je dulu. Itu reality kita. So in those condition, usually either we take multiple measurement ataupun kita minta kawan kita buat measurement. That's why when you do lab experiments, we always do in groups. Kalau you kerja nanti pun, bila you pergi site, even you dah expert macam mana pun, biasanya dia tetap akan suruh you travel at least with partners. Kalau dalam bidang elektrik, lagi critical. You measure live condition, right? Current and everything. You tak boleh main assume. Anggap tak ada current. Lepas tu you measure. I have that kind of experience dengan saya punya previous boss dulu. Very interesting lah, but we'll save that story when we can meet face to face. Then the story will be more interesting. Okay, ada tadi yang jawab observational error. Menarik juga sebab nampak macam betul. Mari kita tengok. So observational error introduced by the observer. Maknanya orang yang baca tu dia yang ini kenapa dia tak termasuk dalam case study, sebab dia bukan, yang observational error ni bacaan dia bukan silap, bacaan dia tidak tepat saja. Misalnya dalam gambar rajah ni, in this figure, you can see that the position of your eye will affect the level of the reading from the tube, the measurement tube. So dia bukanlah, kalau dia berbeza, dia tak akan beza jauh. Dia akan around the correct value. Tapi dalam soalan ini, value dia jauh, 47 on 470. So it's not observational error, it's actually gross error, human mistake. Okay, ni 47. Jadi ni gross, jawapan dia gross error lah. So majority betul. Apa dia random error? Saya rasa dia saja je ni, random error ni. So random error is error due to unknown causes. Tak tahu sebab apa. Normally small but unpredictable. Macam tadi, kalau kita tengok contoh ni kan. Contoh soalan nombor ni tadi. Hold on. Okay, ni soalan nombor apa tadi? 7. Soalan nombor 7. So ada 8 bacaan. Semua setting sama. Equipment sama, lab setting sama. Tapi bila measure, letak sekali dapat 532. Measure lagi sekali dapat 548. Dia ada variation. Okay, bila dia ada variation dan kita dah semua perkara-perkara lain kita dah maintain sama, then we can attribute this to random error. So random error ni memang kita buat perfect macam mana pun dia tak akan dapat bacaan yang sama setiap kali kita baca. Tapi keyword dia dekat sini adalah normally small but unpredictable. So biasanya small. So even after you control all the environment parameters and you conduct as careful as possible, there will still be some variation in your reading. Okay, so soalan. Observational error does not apply to digital reading. Yes, in most cases, yes. As far as I know, I don't know cases where observational error can be seen in digital reading. Because digital reading, you akan dapat value tu exactly. But in practical, sometimes we don't necessarily have digital reading. Kadang-kadang kalau kita pergi, macam bidang saya, bidang electrical katakan kita pergi substation, TNB punya substation, ataupun kita pergi power plant. Power plant ni kadang-kadang dah lama, 20-30 tahun lepas, dia masih beroperasi lagi. Jadi masa dia construct tu, masa zaman tu masih pakai analog meter. So in those cases, bacaan tu penting lah selain daripada scale. So biasanya bila you baca meter, digital meter, kesilapan yang berlaku adalah you silap setting lah. Silap setting dia punya range, atau you silap baca titik perpuluhan. So all that is contributed or is categorized under gross error, human mistake. Okay, but so Niza, I'll double check with this one. I'll try to check whether there are any special cases for digital reading, whether they can be observational errors for different types of meters. I'll let you know afterwards if I find any interesting stories. Okay, 12:46. Tak habis lagi. Okay, so question number 11, question number 12, I think I'm going to let you do on your own based on the one that we shared just now. Let's just go through a bit. A voltmeter has the specification as below. Okay, the voltmeter is to be used to measure voltage across resistor. The expected value of the voltage across resistor is 125 volt. However, measurement yields a value of 130 volt. Oh, ini pun soalan teori juga. So expected value 125. Measurement value 130. What kind of error is this? Ini kena calculation juga sikit nak verify. Okay, so let's do this lah. Yang ni saya rasa saya nak buat lah. Okay, the range is 250. The accuracy is plus minus 1%. Okay, the value of the voltage is 125 and the measurement yields 130. Okay, so let's do this. So we have 1%. Question number 11. Question number 11. We have 1% multiplied by the maximum range 250. So we get, what is that? 2.5? 2.5 volts. So the actual reading is 125. Actual reading is 125 volts. Let's calculate. 2.5 divide by 125 is equal times 100 is equal to 2.5 divide by 125 times 100, 2%. Okay, so basically we have 125 volt plus minus 2.5 volt or 125 volt plus minus 2%. So if you take the maximum level should be 125 plus 2.5. So you should get 127.5 volts. And the minimum is minus 2.5. So you should get 122.5 volts. So this should be the range of your measurement. Okay, but the measurement is out of the range. Measurement is actually 130 volt, which is higher, not within the range that should be when you calculate. So what type of error is this? Di luar range. Sepatutnya bila you measure, you dapat dalam range either 122.5 to 127.5. Tiba-tiba you measure, you dapat 130. So the answer should be, of course, not gross error, not random error, but systematic error. So what kind of systematic error? Bawah systematic error ada instrument error, environmental error dengan observational error. So the answer for this question is instrument error. Jadi kepentingan kita buat soalan-soalan begini adalah supaya bukan sekadar kita nak dapat jawapan dia, kita nak faham apa maksud di sebalik soalan tu. Apa yang kita nak faham daripada soalan tu. Sebab nanti bila kamu berdepan dengan real situation, kita bukan main dengan soalan-soalan macam ni. Kamu nak kena gunakan common sense untuk solve a problem. So saya tekankan tentang pemahaman di sebalik tu. Kita nak faham apa maksud di sebalik soalan tu. Apa yang dia nak kita faham. That's the idea. Okay. The last question. Now it's already 12:51. Okay, so the last question, let's take just an overview lah. If you have time, if required, then maybe. Okay, Aisyah, thank you for your answer. And Arif, a voltmeter and ammeter are to be used to determine power dissipated in a resistor. Okay, dissipated maksud dia tenaga yang diserap, okay, ataupun digunakan oleh satu-satu resistor. Both instruments are guaranteed to be accurate within plus minus 2% of full scale deflection. If the voltmeter reads 200 volt on its 300 volt range and the ammeter reads 80 milliamps on its 100 milliamp range, determine the power across the resistor and its limiting error. Ni senang je. Okey, yang ni saya serahkan untuk anda buat sendirilah. Prinsip dia sama macam soalan-soalan sebelum ni. The principle is the same. We are going to utilize because we want to calculate the power and it uses voltmeter and ammeter. Okay, so you do the calculation. I am just going to share, if you want to convert this question into diagram, what does it look like? Okay. Let me double check the question. Guaranteed. Okay, to determine the power. Okay. If you want to measure power in a circuit, so you have a simple circuit here. So the way we convert it into diagram form is like this. Okay, the original is going to be, we have a source, maybe DC, maybe AC. So if you have a DC source like a battery, we are going to have something like this. Oh, tak sambung pula. Okay. Okay, pardon my drawing lah. My drawing is not that good on this tablet. So if you want to measure the power, we can use either a power meter, it's already embedded in a power meter, or we can use a combination of voltmeter and ammeter. So the way to connect it is, for the ammeter, we need to connect in series. Kita kena sambung dia secara sesiri. So the ammeter must be connected in series here. So the current passes through the ammeter. And for the voltmeter, similar to the question just now, we need to connect it parallel to the component that we want to measure. So we can use the equation P equals to V multiplied by I, and the percent of error is going to be the percent error of the voltage plus the percent error of the current. Okay, so the mathematics straightforward. I'm going to leave it to you. Okay, that sums up our lecture for today. Now it's 20:55, just nice. So tomorrow we are going to start to cover this topic here, which is calibration and noise, where I'm going to explain to you about the principle of calibration and a bit about the theory of noise during measurement. So again, we are going to cover on electrical measurement, but for mechanical or manufacturing student, you can also apply these types of noise. For example, when you want to measure vibration, when you do your manufacturing processes. So vibration is also a type of noise that can be related to your measurement. So you have a specific subject, I think you're going to take in 3rd year or 4th year when you understand about vibration. It's very interesting. So electrical engineers, we also study electrical vibration. Mechanical or manufacturing study about mechanical vibration, and then we combine them together in our design process later on during our working days. Okay, so that's it today. Thank you. Bagi student direct entry, macam mana yang attendance week 1 and week 2? Okay, now we are going to address this one separately. So I'm going to consult with the KJ, with the head of department, to see how we go about. Okay, so don't worry too much. This is common, week 1 and week 2. Next class for BEChem will be on Wednesday, right? Yes. Actually, you can join either one. You can join, for direct entry students, you can join the class tomorrow. I'm going to repeat the same class on Wednesday. So tomorrow the class will only be about 1 hour. For today's attendance, you can log into ULearn and you can register your attendance manually. Okay, I already set from 11 AM to 1 PM. Let me extend it a bit. If maybe many of you may not have time to do it now. It's already 12:57, so hold on, let me extend it a bit. Okay. So I already extended until 1:30, so you can register your attendance there if your name is inside lah. If not, then I also have the option of downloading the let's see. Yeah, I can download it here, attendance list. Okay, so I'm just going to download it now, and it will serve as a backup. Okay. Okay, that's all for today. Thank you for your time. Please don't log out first. I'm still downloading your attendance. Okay, already downloaded. Thank you. So, see you either tomorrow or Wednesday. Have a good day. Semoga bermanfaat the class for today. and see you again insyaAllah. Assalamualaikum and good afternoon.
Waalaikumsalam.
Thank you, Doktor.
Okay, welcome.
Thank you, Doktor.
Alright.
Thank you, Doktor.
Alright, welcome.